All right, so hopefully after thinking about it for a minute, you realized that the item that's probably the most inelastic is electricity to power your home, right? So answer choice B. Couple of reasons, right? That's less of a luxury and more of a necessity. Okay, so there's that. Now, compared to a new house is a very large ticket item, so it takes up a huge portion of a person's budget. So compared to that, it's a small ticket item. Specific brand of breakfast cereal, so that's a very narrowly defined item. So it's going to be, there's going to be lots of substitutes, right? So you're talking about like Kellogg's Raisin Bran. That would be a specific brand of breakfast cereal. There's lots of substitutes there. And then a new vehicle, kind of like a new house, would be a large ticket item. So A, C, and D would more likely be relatively elastic. B is the only thing that is most likely very inelastic. All right, so now to get into a little bit more detail here. So there's a specific formula for this. So like we've been saying, this is a measure of responsiveness. So this is actually something we can calculate, and the measure is gonna entail a number, a specific number. Okay, so the price elasticity of demand, which we will denote E sub D, you see there in the middle. It's equal to, or defined as, the percent change in quantity demanded divided by percent change in price. Okay, so a shorthand notation here is what we see in the large font formula. Of course, recall that the triangle letter delta, Greek letter delta, means change. So for short form, we can write it as percent change in quantity demanded, QD, divided by percent change in price. Okay. So here's an example, a way to calculate it if we were given some values for these things. So suppose that university parking pass prices increase by 50%. So that's percent delta P. So that's what goes in the denominator, is plus 50% because it is an increase. And suppose as a result, the university observes that there are 25% fewer people purchasing a parking pass. So a decrease of 25% or negative 25%, that would go in the numerator. And then if we plug those into our formula, that spits out a negative 0.5. Okay, so there's a numerical example of how to use our formula for price elasticity of demand. Okay, pretty straightforward, especially when we're already given the percentages. It'll be a little harder when we're not given the percentages, but we'll see that in a minute. But first, let's think about what this numerical result means, right? It basically means that if the price of a parking pass rises by 1%, then the quantity demanded will fall by 0.5%. And what that means is that the demand for parking is not very price elastic. The percent change in quantity demanded is smaller than the percent change in price. So, in other words, relative to the change in price, the change in quantity demanded isn't very much. It's only half as much, in fact. So this is when we say this would be an example of something that is price inelastic. Now, let's think about why it's negative. You may already have a good idea about why it's negative, but basically it's because of our law of demand, right? The inverse relationship between price and quantity demanded. So as it turns out, price elasticity of demand will always be negative because of the law of demand, because of the inverse relationship between price and quantity demanded. They move in opposite directions, right? So if price goes up, quantity demanded goes down. And so we will always end up with a negative number for our price elasticity of demand. All right, so some more practice. Suppose that the price of a candy bar increases by 100%, so plus 100%. And as a result of this, you decide to purchase 50% fewer candy bars, so negative 50%. How would you describe your demand for candy bars? So if you need to, go ahead and take a moment, pause the video, and think about this for a second.